Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang, and we have a special episode for you folks today. Today we're going to talk about one-to-one functions and their inverses. Luckily for you folks at home, we have a special guest. He uses math to fight crime and protect the innocent. He's like a math superhero. He's Professor Jay Cho.
Thank you for your
Jay,
introduction.
how's it going, buddy?
Not so good, not so good.
What's wrong?
I had a car accident.
Someone hit your Ferrari?
Well, actually, not exactly a Ferrari. I ended up getting a Fiat, kind of same car.
Did you manage to see who did it?
No, it was so quick. I got out to see who did it, and by the time it was too late, this person was gone.
Don't worry, Jay. I think I know just the person to help us solve this heinous crime.
Ooh, who could that be?
He uses math to bring light to the darkness. He's lead investigator of CSI Pasadena. He's Dr. Richard Abdelkarim. How's it going, Dr. Richard Abdelkarim?
Actually, it's Detective Dr. Richard Abdelkarim, and it's going pretty well, thanks. I'm fighting crime, improving lives. It's pretty fulfilling work.
Awesome.
So, Jay, tell me what happened.
Well, I was sitting in my car, texting.
Wait, you were driving?
No, never. Don't text and drive.
What were you texting about?
I was kind of going through a breakup.
What? You broke up with someone via text message?
Well, it's 21st century, things happen.
So, did you see who hit you?
No, it happened so quick. I got out of the car to see, and then it was already gone, so...
Okay, you're sitting in your car, focus on your text messages, someone hits you in the rear of your car, drives off, you see nothing.
Yeah.
And when did this happen?
Friday afternoon, 12:30-ish.
Okay. Well, lucky for you, we've already sent out our forensics experts to check out your car, and they found out that the car that hit you was red.
How are we going to use this information to help us, Richard?
Well, first, let me check and see how many suspects we have. Okay. We have 3 suspects.
Okay.
Yeah. So what we're going to do is, since forensics found traces of red paint, what we're going to do is make a function that maps a car to its color.
Wait. Remind us again of what a function is.
It's a rule that associates an input to exactly one output.
Can you give an example of a function?
Yeah, so let's take our friends Joffrey and Chelsea.
Okay.
Yeah, so Joffrey's mother's maiden name is Lannister. Chelsea's mother's maiden name is Rodham. Okay, so if we make a function where we map Joffrey to his mother's maiden name Lannister and Chelsea to her mother's maiden name of Rodham, that would be a function because each input has exactly one output. Everyone only has one birth mother, so there can only be one maiden name for that mother.
Oh.
Okay. I think I get it. Can you give us an example of something that's not a function?
Well, let's take our very own JHO right here. If we made a function where he's the input and his output are his birth parents, both his birth parents, then J would be mapping to Papa Cho and Mama Cho. And that would not be a function because there would be 2 different outputs for the same input.
Oh, I get it. So how can we use this function thing to fight a crime?
Well, what we're going to do is we're going to create a car color function.
Okay.
So in this function, what we have on the left is the cars, and on the right is the colors of cars that are our 3 suspects. Notice, first of all, that car 1, car 2, and car 3 are either red or black.
Okay.
Car 1 and car 2 are red, car 3 is black. And that's why in this diagram that we have here, we have car 1 pointing to red, car 2 pointing to red, and car 3 pointing to black.
Wait a minute. So is it okay? I noticed that car 1 and car 2 both point to red. I thought, is that okay to have 2 things pointing to one color?
Yeah, this is still a function because the inputs are going to only one output. A car was only going to have one color.
Oh, okay.
Car 1 only has the color red, car 2 only has the color red.
All right. Cool.
These cars on the left here, is there some special name for those guys over there?
Yeah, the set of input values is called the domain.
Ah, I see. And in this particular case, what's the domain?
The domain is car 1, car 2, car 3.
Okay. And what do you call those things on the right there?
That's called the range. Those are the output values. The set of output values is the range, and that would be the colors red and black in this case.
So how are we going to use this to help us figure out who, hit Jay's car?
Well, there's a problem here. We can't actually use this function to solve the crime because this function is not one-to-one.
Wow, it's not one-to-one. Darn it. Darn it.
Wait, what is one-to-one?
One-to-one function is when each output has only one input.
So why is this function not one-to-one?
Because when you look at the color red, it comes from either car 1 or car 2. So it has two. It comes from two different inputs.
Ah, I see.
Yeah, unfortunately.
Richard, how would having a one-to-one function help us solve this crime?
Well, let's pretend for a second that car 1 is green, car 2 is red, and car 3 is black.
Okay.
So then what would happen is each output comes from only one input.
Oh.
Okay, so this would be a one-to-one function if this were the situation. And what we would be able to do if this were the situation is we could reverse the arrows.
Reverse the arrows? Mind blown. What is this new function called, Richard?
We call this function the inverse function.
Inverse function?
Mind blown again.
Yep, it's the inverse function. Wow. So what you notice in this function is that the domain is now on the right side because the arrows are coming out from the right side. Our set of inputs is the colors. So the domain of the inverse function is actually the range of what our original function was.
So it seems like the domain and the range are kind of switched.
Right, exactly.
Oh,
Okay.
cool. So why do we need our function to be one-to-one in order to solve this?
Well, let's take our actual situation and see what happens when we reverse the arrows. So if we reverse the arrows coming out of red, what do you notice?
Oh wow, then red goes to car 1 and red goes to also car 2. So it doesn't make sense.
Right. You have two outputs for the same input
Right.
in
so
this
it's
inverse function that we
means
created.
I don't know if it's car 1 or car 2 who hit me for sure.
Right, right. So
it's
that's
not
why
gonna
this.
work now.
That's why it's not a one-to-one function. That's why we can't use this to solve the crime.
Oh, that's very unfortunate.
What would an example of a one-to-one function that could help us solve this crime be?
Well, if Jay could remember the license plate of the car that hit him, because we didn't just get the car colors, we got the license plates of the three suspects' cars.
Do you remember seeing the license plate?
Not really.
Man, if only we had an expert hypnotist with us.
Well, luckily for you, I am an expert in speed hypnotism.
What? I don't believe in that.
All right, Jay, focus on the rear view mirror.
Oh, I see a license plate. It says 2HOT4U. I think that's it.
You see too hot for you.
Uh-huh.
Okay. All right. When I snap, you'll be back with us.
Oh, well, what happened? What happened? Did we solve the crime?
Oh, we just made you do a bunch of stupid dances.
What? Oh,
Nah, he's kidding. We actually got some useful information out of you for once.
Cool, cool.
Yeah, so if you take a look at the function we have now, it maps each car to its license plate number.
Okay.
And notice that this function is one-to-one because each output here, the outputs now are the license plate numbers. Each output comes from only one input, which means it's a one-to-one function.
Which means we can reverse the direction of the arrows.
Exactly, and too hot for you, the one you saw in your hypnotic trance, goes to car 1.
Thank you, Richard. You've solved our crime.
No problem.
So for all you folks watching at home, remember, a function needs to be one-to-one in order to have an inverse. Don't break up with someone via text message. And be good, because crime does not add up.
Bad boys, what you gonna do? What you gonna do when